If you closely observe the rotor shaft, you'll be able to see the sliding widths relative to the journal bearings. These parts of the rotor shaft are the journals by which the rotor shaft is supported. Install the journal bearings on the removed rotor shaft. With this journal bearing sliding part, use a dial gauge to measure the clearance between the inner surface of the journal bearing and the rotor shaft with the upper side of the inner surface pressed against the shaft. Compare the measurement with the clearance standard table. If the metal surface appears to have many scratches or to be deeply scratched when you perform the inspection, replace the bearing with a new one. Do not attach the dial gauge to the rotor shaft. If you did, the rotor shaft would get magnetized. A pin for locking is located on each journal bearing. If the pin diameter has been worn by 20% or more, or the pin is bent, replace the pin with a new one. Measure the diameters of the sliding parts and the diameters of the adjacent areas. If the diameter of either sliding part is at least 0.02 of a millimeter smaller than the diameter of the adjacent area, please contact Mitsubishi Heavy Industries. Make sure the claw clutch of the impeller is free from abnormalities such as gouges and cracks. If at all possible, perform a die penetration inspection on the back of the impeller and on all of the blade surfaces. If the inspections show any defects, replace the impeller with a new one. The impeller is made of heat-resistant aluminum alloy. To clean the impeller, wipe it with a sponge or other soft item soaked in kerosene or warm water. Do not use a wire brush or any other hard object. To clean the turbine blades, dip them in a container of warm water to remove the deposited scale. After removal, clean the blades. After washing the turbine blades, dry them thoroughly and coat them with rust-proofing oil. Note also that the turbine blades are made of magnetic material, so it's possible to perform magnetic particle inspection on them. Like the turbine blades, clean the nozzle after washing in warm water. After cleaning the nozzle, dry it thoroughly and coat it with rust-proofing oil. To inspect the nozzle, place it on a stable, flat surface in a well-lit location and give it a visual check for abnormalities. The air filter must be cleaned at least once every 2 months. Soak the filter for 2 to 3 hours in lukewarm water in which a cleaning agent has been dissolved. Then gently wash the filter by hand. After washing the filter, dry it thoroughly by placing it in a shaded location that's well ventilated. The vacuum breaker is attached to the side of the pedestal. Remove the bolt, pull out the vacuum breaker, and make sure that there's no abnormality in the valve disc and that the valve operates smoothly. There's an inlet for sealing air near the diffuser blades on the pedestal compressor side. Check that there's no evidence of lubricant leakage into the sealing air channel. Also, check the continuity of the channel by feeding general service air into the channel and confirming that air emerges from the turbine end. The procedure for reassembly is basically the reverse of that for disassembly. Before starting reassembly, though, you must thoroughly clean the rotor shaft, bearings, and other components, and make sure there's no foreign material in the pedestal. Also, replace all tongued washers, O-rings, gaskets, lock plates, stainless steel wires, and other consumable parts with new ones. When installing the bearings in the rotor shaft, take off your work gloves and work with bare hands. Take care not to allow foreign matter to contaminate the components. For reassembly, follow the disassembly steps in reverse. Install the compressor side journal bearing to the bearing pedestal. Install the turbine side thrust bearing. Install the turbine side journal bearing to the bearing pedestal. Install the turbine side oil labyrinth. Install the gas labyrinth. Attach the support to the compressor side of the bearing pedestal. Attach the rotor guide pipe to the compressor side of the rotor shaft. Attach the pulling out tube to the turbine side of the rotor shaft. Put the cable around the large diameter part of the disc end of the rotor. Clean the rotor shaft and apply plenty of lubricating oil to the area over which the bearings will pass, from the rotor guide pipe periphery along the rotor shaft. Slowly insert the rotor shaft into the pedestal, taking care not to damage the fins of the turbine side oil labyrinth. Coat the turbine side thrust bearing and thrust collar with lubricating oil. Screw the threaded bar into the thrust collar and attach the thrust collar to the rotor shaft. Attach the support with the compressor side thrust bearing and oil labyrinth on it to the pedestal. Insert the sleeve partway along the rotor shaft and align the match-up markings on the sleeve and rotor shaft. Align the claw clutch of the impeller with the groove in the sleeve. As you do this, make sure the match-up markings on the sleeve and impeller are aligned with each other. While observing the back of the impeller, push on the impeller so it engages precisely with the sleeve. When you've confirmed the fit between the impeller and sleeve, push the impeller all the way in by hand. Then fit the nut onto the end of the shaft and tighten by hand. Then screw the hydraulic jack into the end of the shaft. When you have screwed the jack in fully, give it one reverse turn. Install the hydraulic pump and raise the hydraulic pressure to the specified level. After raising the pressure, insert the rod through the slot in the hydraulic jack and use it to turn the nut until it stops. Open the relief valve and reduce the hydraulic pressure. Increase the pressure to the specified level again. Check that the nut cannot be turned further. Remove the hydraulic jack. Use a vernier caliper or depth gauge to measure the distance from the end of the surface of the nut to the end of the shaft. Compare the value with the one obtained before disassembly and confirm that the difference is less than 0.1 millimeter. Turn the rotor shaft by hand clockwise. Confirm that it rotates smoothly and without contact noise. Set a dial gauge on the end of the rotor shaft and use it to measure the deflection in the end of the rotor shaft. If the deflection is 0.1 millimeter or greater, there may be foreign matter on the contact surface of the impeller, sleeve, thrust collar, or rotor shaft. When you do this, remove the impeller again and check the contact surfaces. Now measure the thrust clearance. Set a dial gauge on the end of the rotor shaft just as you did before disassembly. The thrust clearance is the difference between when the shaft is pushed and when it is pulled. Check that the clearance is the same as it was before disassembly. Use Use the clearance gauge to measure the clearance between the turbine blades and the gas outlet guide at top, bottom, left, and right. Check that the clearance conforms to the standard value, and for details of clearance standards, please refer to the clearance table in the instruction manual. As you did during assembly, make sure there is no contact with the impeller. Fit the inner scroll to the outer scroll and attach with the hex bolt. Use the clearance gauge to measure the clearance between the air guide casing and the impeller blade tips at top, bottom, left, and right. Check that the clearance conforms to the standard value, and for details of clearance standards, please refer to the clearance table in the instruction manual. Hoist the silencer and fit it to the scroll. Tighten the retaining nut firmly. Connect the tachometer cable to the terminal in the terminal box. As you've seen, the MET83SE turbocharger is designed so that people with a reasonable amount of experience can disassemble, inspect, and reassemble it. Nevertheless, the procedures include dangerous tasks, such as hoisting heavy components. It is vital for people performing these procedures to have the skills and knowledge needed to work safely and for them to work under safety control. Carefully reading the MET83SE turbocharger instruction manual and understanding its content will help enable you to work safely. Using your knowledge of both engines and turbochargers, you'll be able to play a role in ensuring safe voyages.